Hello there. Okay, so for today we will look into LEPAK, Marvel Chapter 4. Okay, so for the first question, you're given coefficient of kinetic friction. So you have a box. So over here the box has a mass of 20 kg. And then the coefficient given is 0.3. So this one you have the value of the mass m. Coefficient over here given. So and then over here they wanted to determine how much of work does a pulling force do on the box in pulling it 6 meter. So the displacement over here is 6 meter across the floor at constant speed. So that means you're pulling at a constant speed. And then the pulling force is directed 35 degrees above the horizontal. So over here they want you to draw a FBD and show all your steps clearly. Now the first thing what you have to do is that you need to draw a FBD. So that means you have a box. So over here located. So at the surface that means you will have a normal force. Normal force over here. And then you will have weight over here. So let's say this is the plane. And then let's say you have a force acting 35 degrees above the horizontal. So you're pulling it. Coefficient given, that means in opposite direction you will have friction. So opposite you will have frictional force. So this is the FBD. So once you have done with the FBD, we can move on to look at the solution lah. So for the solution, first we look into vertical component lah. So vertical component total Fy force will be equivalent to 0. Because the object is not being lifted. So now this one, the force, you can resolve it into two components lah. So if you resolve over here, you will have Fx component. Resolve it over here, you will have Fy component. Now for the vertical component, total vertical component will be equivalent to 0. So that means on y-axis positive you have n and Fy. And then below you have weight lah. So that means n plus with Fy component minus with weight will be equivalent to 0. So what we can do is that further expand. N plus Fy will be equivalent to F sine. Look back at the angle which is 35. And then weight will be equivalent to mg equivalent to 0. So this one we have one equation lah. So what I do is that now rearrange in terms of n, which will be equivalent to mg minus f sine 35. Get equation 1. Now done with the vertical component, we move on to horizontal component. So since it is moving at constant speed over here, constant speed, so that means you have motion over here, v is equivalent to constant. So therefore your acceleration will be equivalent to 0. So 0 acceleration, so that means total Fx will be equivalent to 0. So this is for the horizontal component. So for horizontal component you only have two components, Fx and friction. So in the direction of motion we take it as positive, so that means moving toward your right. Fx is positive, so that means Fx minus with friction will be equivalent to 0. So if you expand, Fx will be equivalent to F cos angle is 35 minus with friction friction will be equivalent to coefficient times normal force equivalent to 0. Okay. Alright. So this one we get equation 2. Okay. Equation 2. So what we now can do is that replace equation 1 into equation 2. Okay, so replace equation 1 into 2. So that means f cos 35, okay, will be equal, okay, so if you move it over here, equivalent to coefficient n, okay, so f cos 35 will be equivalent to coefficient, okay, so where the value of n, okay, so over here is equivalent to mg minus f sine 35. Okay, so now we have replaced all the value. Okay, coefficient is already given in the question. Value of m given, g constant. Okay, sin 35 you can simplify, and cos 35 you can simplify. Okay, so only the unknown value over here is that f. Okay, so now what you do is that you solve this one, replace in, find the value of f. Okay, where f you will end up with 59.38 Newton. Okay, alright, so once we have the value of f, we can go to calculate the work done. Okay, so therefore, okay, work will be equivalent to fs cos theta. Okay, so just replace in over here. Okay, so f given 59.38, okay, times displacement where we have 6. Okay, refer back at the question. Okay, so we're pulling it 6 meter. Okay, 6 cos 35 degrees. Okay, so solve it, you will end up with the total work done, where total work you will end up with 291.8 joule. Okay, so this will be the final answer which we are looking for. Okay, so right now done. Okay, now we look into the marking scheme. Okay, okay, now over here they will look at the your free body diagram. Okay, so you have 4 components, the main component only counted. Okay, so let me change it to red first. Do we have red? Okay, never mind, just leave it as orange lah. Okay, so 1, 2, 3, 4. Okay, so all 4 correct. Okay, so you will get 3 marks lah. Okay, so now let's say you make a mistake. Okay, so that means you only got 3 correct, you get 2 marks. Okay, if you only got 2 label correct, you will get 1 mark. Okay, so for the label, okay, you must have arrow together with the label. Okay, make sure you don't forget your angle over here. Okay, so that means over here full mark 3 marks lah. Okay, so here 1 mark, here 1 mark, here 1 mark, here 1 mark. Okay, so 1, 2, 3, 4 correct, you get full mark, which will be 3 mark. Okay, alright, so move down over here, you get the concept over here correct, total y component 0, concept 1 mark. Okay, you can form the equation. Okay, 1 mark. Alright, so the same over here, concept over here, 1 mark. Okay, you can form the equation. Okay, correct equation, 1 mark. Okay, and then over here, replace. Okay, find the answer. Okay, replace. Okay, answer with unit, 1 mark. Okay, so over here for the equation, you replace the value, 1 mark, answer with unit, 1 mark. Okay, so the full mark over here, if you count back, okay, altogether you will get 10 marks over here. Okay, so total marks will be 10. Okay, that's all for today. Okay, do give it a try. Okay, enjoy learning physics. Thank you.